Hello, and welcome back to the MCAT grind. We have Biology Chapter 3, Embryogenesis and Development. This takes up very little yield on the MCAT, but still we'll go over it to make sure you get that one question that you're definitely gonna get. So, starting on development, we have the process of fertilization, which is sperm and egg coming together and forming the zygote. In that formation, the sperm uses the acrosome on the very tip to pierce through into the egg, and that uses calcium. Then we have cleavage. Cleavage is the rapid divisions of the zygote into the smaller cells. So as it travels through going into the uterus, it will start dividing, but it will remain the same volume of a ball into morula. So from zygote into a morula just has a lot more cells. Now, once it arrives near the uterus, it will undergo blastulation, which it will hollow out and filled with fluid inside. The inside part is called blastocele. Cele is C-O-E-L, which is like the whole inside. And the fluid inside encapsulates with the little ball and the little cell mass. The inner cell mass will be what becomes of the organism, typically the baby, and the outside cell layer is called the trophoblast. And the trophoblast becomes the placenta and the umbilical cord and the corresponding structures. And the inner fluid will be what becomes of the amniotic fluid, and that absorbs the impacts and helps stabilizes the fetus in the middle. Gastrulation is the splitting of the germ layers. So, as the blastula forms like so, there will be an invagination of the blastopore and all the way to the other side, during which this will become a gastrula, and you will have different part of germ layers. The outer part will be called the ectoderm, which will form the outside, like the skin, the hair, and your central nervous system and your nervous system structures. Mesoderm will be your muscles, circulatory system, most of your excretory system. Endoderm will be your digestive system and your tracts, your lungs. Neurulation takes place when it develops your nervous system. So at the very end of gastrulation, you will have what's called the nodal cord. The nodal cord is of mesodermal descent, and the nodal cord will trigger the development of the neural fold, which are the ectodermal cells, to form. So they'll fold together, and they will become the basis of your spinal cord. And on the very anterior part will be the brain, and there will be tiny ectodermal cells on the side called neural crest. And neural crest cells will migrate around to become the peripheral nervous system. So your cranial nerves and your nerves all around, that's not other than your brain and spinal cord, are all in the peripheral nervous system. Right, now we have mechanism into how it's done. Starting off, we have a cell that undergoes specification. You can think of it as assignment for cell lineage, so it is still reversible. Think about a class of children being assigned, okay, what will you be doing for a school festival? Okay, I think I will prepare and do some food stands. Or another say, oh, I could do some origami, or I could make some arts and crafts. Now, this is just an assignment, right? So if they so choose before the deadline, they could say, oh, sorry teacher, I want to switch to another role. So that's just specification. They specify what they want, but it's not absolute deadline. They can reverse it. Determination is then when you reach the deadline and it's irreversible commitment, saying, okay, after deadline, you have to get started on your project. and you have to start thinking and designing around your project. Time to do. And differentiation is the actual changing of the characteristics to the cell into that tissue type, or that cell type of the tissue. So you can be thinking about, okay, this person actually committing to making the costume and is changing the characteristics into it. So for perhaps hematopoietic stem cell, it would have to take on certain characteristics. Next, we have fetal blood. Fetal blood is different from adult blood in that it has higher O2 affinity than adult hemoglobin. This should be true because it takes in more oxygen, right, to uptake and get more nutrients. So later in biochem video, you will see the oxygen shift curve, and you will see that fetal hemoglobin will absorb more oxygen and shift on the curve. Foramen ovale, ductus arteriosus, and ductus venosus. These three are specific structures only in the fetal blood. They are shunts that direct blood into a more efficient way through the fetus. The foramen ovale is from the right atrium to the left atrium, present in the heart. Because the fetus has non-functional lungs at the moment, they can't breathe outside, it's just fluid outside. So the blood from the right atrium will be directed straight to the left atrium and skip the lungs. Ductus arteriosus travels from a pulmonary artery into the aorta. So the right atrium will still have some blood going to the left atrium, and some will still go to the pulmonary artery, but that is still useless. It's not going to the lungs because the lungs is non-functional. So it will travel from the artery directly to the aorta and pump through the systemic circulation. Ductus venosus is a shunt that travels directly from the umbilical vein to the inferior vena cava. Because of the umbilical vein takes all the oxygenated blood towards the heart, they can skip the liver at the moment because the liver is non-functional. Typically, the liver will help clean blood and make it suitable, right? So it will bring it straight up to the inferior vena cava, into the heart, and pump through the circulation. Now, on the other hand, umbilical artery sends the wastes to the placenta and will send to the mother. Gestation are several developmental stages. So we have trimester 1, 2, and 3. In trimester 1, most of the organs are developed. So that includes the brain, the eyes, the arms, the limbs, and all the internal organs inside the baby. Now, the fetus at this point is only about 9 centimeters long. The heart begins beating around 3 weeks, and by 8 weeks, most of the things are already intact. In the second trimester, there will be more growth, a lot of big growth, and the facial structures definitions. So it's about second trimester that you can typically determine the facial features and go for ultrasound and see the physical features and the shape. In the third trimester, you can see the brain developing a lot more into its final stages, as well as antibody passed from the mother to the child. And it is especially important in the 9th month. All the antibody and most of the defenses will go into the baby because, well, the baby needs all those to have a good digestive system, a good immune system, and such. So you would notice that some babies that are born a little earlier, they may have immune compromises, and those would be sticking very hard to fix. So there are, of course, technology that supports the neonatal unit and could support early births. All right, and that's about it. Take care.